Now, next up on the docket, we have the amazing Scale Computing team. Some of you probably will recognize this name, David Demlo. He is the Vice President of Product Strategy, and always good to see a familiar face here on the EcoCast. With that, again, send in as many questions as you can. I know we can't always answer all of them, but we do have that best question gift card going out for each session. And of course, we just want to make sure that you get the information you're looking for here today. And with that, I think, David, are you ready to take the floor and kick things off here?
I am ready. Yeah, thank you very much. And thanks everyone for joining.
Take it away.
All right. So hi, I'm Dave Demelo. I'm the Vice President of Product Strategy at Scale Computing. We're going to talk about, obviously, multi-cloud management, but really focus on the application side of things and how to centrally manage and deploy applications and infrastructure fleets from public cloud out to highly distributed edge environments, which adds some interesting complexities. To kind of set the stage, we're focusing a lot on the cloud component piece, but really want to focus on, the whole distributed computing spectrum from, edge clouds to obviously public cloud, your core data center, private cloud, regional data center. One of the things that's we're seeing is, particularly as applications are refactored, the concept of an application running in a place, figuring out, oh, this application should live in the cloud or this application is in the edge is almost going away to where, we're finding distributed applications that have, data ingestion and analytics and inference pieces that run out close, to an edge or close to people or things or devices. And then, centralized, data lakes that are providing, long-term analytics, refining AI models, things like that. And so, we're really trying to, focus on that as the ultimate deployment platform for building applications, for deploying applications, and that there'll be individual pieces from legacy virtual machines to new cloud native type solutions that will get deployed and then ultimately moved between clouds, between locations as needs change. So as an introduction to scale computing, our overall solution that we're going to talk about is Scale Computing Platform. And it is, a platform for running applications in any locations, from on-premises to distributed edge, to data center, to private, to public cloud, and running any types of applications. So, everything from, your virtual machines that, have been the old faithful for years and years to applications that have been, refactored, distributed in containers, Kubernetes that have unique characteristics on their own. And, we also see, providing unique capabilities and services to different classes of users. And, this is kind of a new thing. So many of you, I imagine, are, represent the infrastructure teams, and you're used to a particular set of interfaces, centralized control plane for the infrastructure, for deploying applications, automation tools, things like Ansible, for example, to let you manage that infrastructure, deploy applications, maybe even reach into other infrastructure components and so forth. And do that across multiple locations. One of the things about these tools and centralized fleet management is that ability to see the entire enterprise in multiple locations in one place. What we're seeing increasingly is a new set of demands coming to us as an IT supplier, coming to you as the infrastructure team, from, for lack of a better term, from the applications team that's responsible for building these applications, refactoring these applications, updating, patching, or taking applications that maybe were originally written to run in a, cloud-based Kubernetes cluster, but now have components that, due to, we heard the term earlier, data gravity, need to be portions moved out to, particular locations, whether it's for compliance reasons to keep the data private and secure, whether it's for performance reasons, so on and so forth. And so they need to be able to view this entire distributed environment, that's distributed computing spectrum that I talked about, through the same set of tools. And so we want to enable that in a lot of different ways. But one of the, the key ways is we want to be able to integrate with tools that in many cases are already being used. And so we see a number of customers, for example, and these are just examples. We'll go through a bunch of different cloud providers, want to kind of give some blueprints to how we see hybrid cloud integration being done. And these are things that, you can go out and try, and probably are doing many of them already. So we'll kind of dive in, but most of these, again, are examples, apply to different cloud providers, but fall into kind of two categories. One is extending on-premises infrastructure and applications into public cloud. In this case, Azure, but could be others. So extending storage, extending compute, extending networking, so that applications that need to run on premises can tap into resources like excess storage, can like machine model updating and training and so forth for those applications that are generally edge centric or deployed on premises. Leverage and extend using cloud resources. And then the other often comes into centralized management from some type of centralized cloud resource. The first thing, and I think Dan mentioned it right off the bat, identity and access control, RBAC, role-based access control is just a huge thing. And, we see that anymore just, as a de facto being cloud-based. So whether that's, synchronizing with existing on-premises, Active Directory, other security services, using things like, Azure ID, Entra ID for centralized control of cloud-based authentication and management, not just for those cloud-based resources, but extending that out to on-premises is really one of the key design patterns. In the case of our solutions, so we've implemented OpenID Connect, so you can fully utilize something like Azure Entra ID as your, to provide role-based access control to any system or components within your fleet, or the applications leverage capabilities like obviously multi-factor authentication and so on and so forth. And we offer that throughout our entire product line, from the on-premises hypercore piece to our centralized fleet management product. One of the other patterns we see is leveraging services like Azure Arc for servers, and we'll talk about equivalents on other clouds, where you can actually deploy management agents out that have the ability through the Azure portal to connect to on-premises systems, resources, applications, and provide centralized management of those infrastructure services. In this case, basically the same way you would get tooling if you were deploying those applications on the cloud. So this is a great tool if you have lifted and shifted, an application previously, you were running it up in Azure, but now you need to move it back out to on premises for, any number of reasons. You can do that and still maintain the same kind of, update policy, centralized policy, log analytics, all the things that you were used to running that application in Azure. And then, also leverage additional capabilities, like being able to access remotely. And I've got a couple of screenshots here to give you some examples. So this is my Azure Arc Portal. You can see here I've got a whole bunch of machines that are connected into Azure Arc. These are actually on-premises servers. You can see all different kinds of operating systems from Windows, Linux, and these are all running in multiple locations, but I have the ability to see everything in one place, set policies, manage updates, deploy applications, remotely, securely access those for administrative, for troubleshooting, so I can drill down in, connect into those systems centrally. And it, again, provides the comfort and the kinds of service and accessibility that you would expect with cloud-based applications, but lets you place those applications or components wherever they make most sense for your organization. Another similar kind of services when you get into cloud native, there's also a service called Azure Arc for Kubernetes, lets you deploy on-premises Kubernetes clusters, K3S, OpenShift, whatever type of Kubernetes you want to deploy, and then connect it back into the Azure control plane. You can run any, CNCF certified Kubernetes. In this case, you get the same benefit that your application developers get in the cloud, where they don't care what the underlying hardware is. They assume a certain amount of, resiliency. In this case, the on-premises infrastructure can handle and provide all those things that normally would be provided by the cloud, but your developers get the same access as if they were, for example, deploying applications to an Azure AKS cluster running in the cloud or running in another public cloud, for example. Another very common design pattern is, as I mentioned, to extending on-premises storage capabilities with backup, archiving, synchronization. In the case of Azure, there's a service called Azure File Sync, which lets you basically get infinite storage capacity on premises. It looks and acts like it's local. You can maintain a on-premises local cache for recently created access data. You can also automatically archive older files or synchronize those up to Azure Storage, so you have easy accessibility from the cloud. We also see customers that use capabilities like this to actually synchronize data between multiple edge locations. Maybe they publish it out to their Azure file services in the cloud, and the data pushed there gets automatically distributed out to any number of edge locations that need access to that. But a very easy hybrid cloud services where you've got Azure-based cloud storage, you've got on-premises, local, fast, low latency data access that into many types of hybrid cloud scenario. Switching over to AWS, their equivalent service to like the Azure Arc would be AWS Systems Manager, where you can see here you can very easily register your on-premises systems. And again, this can be tens, hundreds, thousands of locations, depending on the nature of your business, that can leverage AWS Systems Manager, connect in, let you group resources, take actions, operations, deploy applications, do change management from a central location, regardless of where that actual infrastructure or systems are being deployed. One of the common use cases we see of that kind of an extension is ECS Anywhere, which is Edge Container Services. Through ECS Anywhere, you can centrally deploy, update containerized applications, have those en masse distributed out to, again, tens, hundreds of thousands of locations. Very easy. And in the same way that your application development team would be used to doing this to push out to AWS or being push out to other public clouds for their application deployment. Another kind of equivalent, we talked about AWS, Azure File Sync. On AWS, the equivalent there would be AWS Storage Gateway, which actually is a nice virtual you can deploy as a virtual machine on premises. You can put it in any number of locations that you have, and it's all those same kinds of capabilities where it can expose, Windows file share interfaces, SMB, NFS, iSCSI even interfaces to provide what appears like infinite local edge-based storage capacity, but that's backed and synchronized up to AWS S3 storage, and then can leverage all the lifecycle management, the encryption, the security capabilities that you would get natively using S3 storage, for example. And finally, another kind of cloud extension example. Google, kind of the father of Kubernetes, offers their managed high value managed Kubernetes service that you can run run in the cloud. It's called Google Anthos. There is a version of that can be run on premises, deployed on virtual machines. And kind of what you see here in this user interface is this again. The point is let developers, let the infrastructure teams that know how to manage these systems not have to worry about where they're physically actually running. So in this case, the second cluster I see here is running natively in GKE. It's a 3-node cluster. I can see the resources. I can set policies, deploy applications, set up GitOps operators, whatever that I need. The same way I can do to this edge cluster that's actually running on premises and connected into Google, and still has access to all the managed high value Google Anthos services that are available there. And these are just examples. There's many other clouds, other type of hybrid cloud solutions. We'll just run through, to mention at a high level. One of the common, hybrid cloud where you see portions of applications actually running in different pieces fall into the IoT or industrial IoT space. And most cloud providers and many application specific or industry specific clouds have their own versions, but Azure IoT is something you can easily deploy on premises, capture and gather and analyze data, machine data locally, do some local processing, stream that up to Azure IoT Cloud Hub services. AWS Greengrass is kind of the similar capability in the AWS ecosystem. So a lot of different hybrid cloud solutions focused around IoT, data management, so forth, that would extend all the way out to again many hundreds of edge locations, and even smaller devices that would come into play here as well. We also see a wide range of multi-cloud Kubernetes and container management systems that are out there. Just a few to name: Avasa, Portainer, IBM Edge Application Manager are several that we partner with. If you do look at, if you're looking at Kubernetes and you're not, you don't want to pick one of the cloud providers like Microsoft Azure, AKS, or Google Anthos, who, by the way, have their own hybrid cloud, where you can run AKS but run Kubernetes clusters managed on Google. If you want a more vendor neutral, there's a whole ecosystem of multi-cloud Kubernetes, independent cloud providers that can work with any of those public cloud ecosystems, can deploy on premises, on SE platform, for example. We see a lot of interest, in those types of patterns. And then, other areas all around edge AI, computer vision. It's very, very common model to see some type of cloud-based, and this could be, vendor specific. This could be more general, cloud-based training of, models, leveraging ML ops to push out new models across, fleets of, imagine, 10,000 retail stores that are doing customer detection or empty shelf detection or things like that, leveraging hybrid cloud to update those models, refine those models, push them out, use distributed ML ops type infrastructure to edge runtimes that are deployed in this, in the on-prem locations. And then, the other kind of area of, hybrid cloud applications or relate to securely remotely accessing resources, whether they're in public clouds, whether they're located on-prem. And some examples that, beyond the, remote access for IT that we showed would be things like Azure Application Proxy, where you can, through the Azure cloud, expose access to any on-premises application, distributed application that has a web interface. You can remote that securely, authenticate and provide access control through the Azure cloud without having to open up your VPN to let even employees have access to those kinds of web-based applications. And then there's similar kind of hybrid models when you get into VDI, desktop delivery, application streaming, any kind of end user compute, how you deliver desktops and applications in some type of hybrid type of model. And ultimately, I think the goal for everyone is to provide really cloud-like management and for distributed hybrid cloud computing, whether that's in 10 locations, whether that's in 10,000 locations, provide a lot of the capabilities, API driven, declarative, the security, all the things that you're used to and that teams are used to running and deploying applications in the cloud. Hide the underlying infrastructure, the hardware, the updates, all those things, turn those into a service that is, your application developers and teams don't have to worry about. The infrastructure teams, can control those centrally. And that's really the goal that we're looking to provide here at Scale Computing. And with that, let's see what questions we have.
All right. We actually have quite a few. So let's dive into it. How does that sound?
Great.
Okay, I'm gonna I got you excited and then now I'm pulling back, but I'm gonna throw up a poll just for everyone here. If you are in the audience and you're looking for a little bit of information from Scale Computing about their solution, click on in there about what you'd like: data sheet, white paper, case studies, pricing, demos, etc. This is your easy button, your wish list. So please let Scale know what you're looking for. And with that, so I've got quite a few questions. Let's dive in. First one I've got here is, what are some key considerations for ensuring governance and security across multiple clouds? Are there any industry standards or frameworks that organizations should definitely adhere to?
Oh, well, that's a broad question. There's definitely many best practices, and most companies are subject to very many general compliance requirements, whether it's SOC 2 compliance, ISO 27001, or often in very vertical or application specific compliance requirements that will set guidelines, audit policies, things like that for all information security, whether it's on-prem, so on and so forth. That's generally the place to start is what you're required to do. I think Dan covered a lot of just the high level, things that you need to, start with: identity management, access control, get those, make sure those are, bulletproof and locked down, and then, go from there.
Right. That sounds good. Another one here I've got is, with the proliferation of cloud service providers, how do organizations choose the right combination to meet their specific needs? How would you go about that? And they mention they want to kind of minimize complexity and maximize flexibility.
Yeah, no, that's a great question. Again, it's The answer is always it depends. I mean, a lot's going to depend on your vertical market need, your set of applications, your scope in terms of physical footprints, things like that. Also depends to some degree on what you consider a cloud provider. I mean, we work with an ecosystem of we would call managed service providers, but many of them provide some type of software as a service or infrastructure as a service or platform as a service that may apply to your particular vertical. They may be using scale computing under the hood that you wouldn't even necessarily know about. So selecting the goal, obviously, to minimize the number of vendors you have to deal with is one. I guess beyond that, the thing I would say is stick with industry standards, portable types of deployment. So virtual machines, for example, you can lift and shift a Linux or Windows based virtual machine, move it around anywhere pretty easily, pretty freely. Not necessarily gaining or losing any capability, but it's a nice portable thing that you can move around and avoid a cloud lock-in. Same thing when you get into cloud native apps, containerized. I think you want to, where possible, avoid getting into very, very into locked in type opinionated solutions. If you're deploying in terms of Kubernetes, for just as an example, I think you want to try to stay with utilizing resources, utilizing operators, value added services that are easily transportable, as opposed to very, very opinionated. If you are again looking to minimize your lock in. And so forth. On the flip side, there are many cases where it's, you don't want to become experts. You want to just, deploy your applications, let somebody else worry about, all those details. And often it, makes sense to get, into a very, very opinionated solution, if that meets your needs and, as long as you understand what your eventual exit plan is.
Yeah, good points there. And mentioning that kind of, do you want to deploy on one cloud, move over and keep yourself nimble? What are maybe like pluses and minuses of that? When and why would you want to stay nimble and jump around in different environments, or when or why would you want to anchor yourself and just kind of commit to one? Again, a bit of a broad question, but.
Yeah. And again, it's going to depend on your company, your application. Often, there can be things from, you may find that, certain public clouds or specialized clouds, don't have the same geographic scope, aren't going to work necessarily in all of the regions that you might want to. So you might have to kind of pick and choose, what's the best of breed, in this particular region. Often network access, although when you get into the very big cloud vendors, that's generally not as much of a concern. But, if you have an application that is very, very network dependent, or you need something with, a lot of sites that are very close to, when we talk about edge, a lot of times, that often does mean, okay, we're running physical servers on-prem in a customer environment, but sometimes the edge is, a telco tower that's, a couple miles away, or, a data center that's cross town, but still low latency networking. And that can make a lot of choices in terms of why you might pick one particular cloud provider. Well, because these are the offices that I have, or these are the areas where my customers are accessing from, and who has the best geographic location, who has the best low latency network access. Sometimes those things don't matter for certain applications, and you can run them all in one big region, and all you're looking for is maybe geographic redundancy for major disasters, if you need to move your application from East Coast to West Coast, or things like that. So there could be a lot of different variables to consider there.
Right. Nice. And then maybe, I think we have time for maybe one or two final questions here, and then I'll let you free. But Here I've got someone asking, can you provide examples of specific tools or technologies that help streamline operations while maximizing the benefits of this multi-cloud? And I guess you could be general or more specific to scale and those tools that you pack.
Yeah. I mean, in general, I think, there's some pretty standard, things like, at scale and really everywhere, you want to automate, you want to leverage infrastructure and applications as code. So, you want to avoid, manual manual deployments, manual updates, anything that's error prone, time consuming, things like that. And there are a lot of different tools depending on what you're utilizing. For the market segments that we serve, we found that actually Ansible tends to be kind of the best of everything. We've implemented our particular Ansible integration in a way that it kind of checks everything from initial configuration management at the infrastructure level to application deployment to even, day two updates, application updates, so on and so forth. And it's a great tool for orchestrating whatever other kinds of integrations you need. I mean, real world example, just today I was working with the Azure Ansible collection to automate, a complete end-to-end deployment of defining a new application in Azure that I then want to, register my on-prem application to, and turning that all into a single, infrastructure as code pipeline, kind of along with the infrastructure as code, whatever label you put on it, some kind of GitOps methodology where you're taking that code, you're version controlling it, you're checking in changes with an approval process, with some automated testing so that you can make changes securely. They go through, security checks, sanity checks, internal testing can be rolled out across, again, if you're assuming distributed systems, and, we very commonly are dealing with, tens and thousands of end sites. So you need to be very careful on how you deploy make changes at that scale. How you monitor those, how you roll back, things if there are, inadvertent changes that accidentally get through. So those would be some of the key things, but there's a lot of different tools. They have, pros and cons. Most of the different toolings, it's not really an either or. They can work together. I know many people who are big Terraform fans, and Terraform makes a ton of sense. I think Cloud, where you can kind of maintain states and so forth, but Terraform can also call your Ansible and vice versa. And so just depending on your needs, depending on how dynamic your environment is, that can make a lot of, that can, dictate a lot what kinds of tools you use, what's best for your environment. And then sometimes it does just come down to skill sets of what you're used to, maybe what you already, again, we try to leverage, how did you, if you're already deploying these things successfully in the cloud or on premises now, and you need to change those locations, how can we keep as much of what you've already built, used, and so forth, and just change the infrastructure underneath? Because ultimately that's, kind of the boring stuff. That's what you care about. And, that's what you don't want to have to care about versus getting your applications deployed, updated, patched, all those kinds of things.
Incredible. No, that's really helpful. And I think that kind of gives a lot to think about, but some really good specific examples of how you're using, these instances and how others might too. So with that though, David, I think we are at time. So my last little question to you is always, where should people go? What's the first step if they want to get started with Scale or learn a little bit more?
Sure. I know we attached a resource here that talks, specifically about, some of the multi-cloud integrations with Azure and a little more detail than what I went through. Certainly welcome you to go to, scalecomputing.com, check out our solution overall, and, reach out if you have, specific needs we can help you with.
Beautiful. Well, thank you so much. I'm going to let you go, but I really appreciate you taking your time to be here today.
Thank you.